Support Basics. About this course. Welcome to the Support Basics course. In this course, you'll explore the intriguing world of troubleshooting. You will learn key ways to hone in on the causes of problems that don't have an obvious solution. Learning objectives. After completing this course, you should be able to define troubleshooting, explain basic troubleshooting methodology, identify key disciplines when creating documentation for support tasks, explain methods and best practices for effective remote troubleshooting. About this module. Module 1. What is troubleshooting? Introduction. In this module, you will discover the intriguing keys to troubleshooting information technology, IT, issues. You will learn how to find root causes to problems by applying induction and deduction, a bit like Sherlock Holmes. Learning objectives. After completing this module, you should be able to compare and contrast perceived problems with actual causes. List questions you can use to find root causes to problems. Explain the importance and complexity of environmental factors. Define induction and deduction. The basics of troubleshooting. Troubleshooting is an approach to solving a problem. Some problems can seem simple at first. But anyone who has tried to get to the root of a difficult problem will say that troubleshooting takes work. Troubleshooting support issues. Skilled support IT professionals who focus on troubleshooting can save you hours of work and save your organization hundreds of thousands of dollars in lost productivity and data. Users and organizations range in skill level, and that fosters a variety of issues. Many problems that IT support professionals solve are relatively straightforward. More difficult problems don't have an easy, on-the-surface solution. Those problems require advanced troubleshooting. Effective troubleshooting involves general techniques that you apply in most support situations. Next, you'll discover some of these techniques as well as troubleshooting steps that you can use as you solve technical problems. Perceived problems and actual causes. The first step in troubleshooting any problem is to understand the symptoms as they're described or presented to you. The word symptom here calls out the fact that what you or a user sees might only marginally be related to the actual problem or not related at all. For example, suppose you're at a restaurant and order a piece of cake. You taste the cake and don't like it. Based on the flavor, you conclude that the baker put too much lemon in the batter. But, in fact, the cake doesn't contain any lemon. A carton of buttermilk was mislabeled as plain milk, and the baker added some of the sour buttermilk to the recipe without realizing the mistake. In this situation, you drew a conclusion based on some assumptions and on what first appeared to you: the cake has lemon in it and someone added too much of the ingredient to the cake. The real issue was that a key ingredient had changed, which gave the cake a sour flavor that you misinterpreted as lemon. Getting clarity. Taking a symptom at face value can lead you in the wrong direction. If you're an IT professional, getting very clear on what the user is experiencing will help ensure that you're not investigating the wrong problem. Root causes. To find root causes, take a Socratic approach. When you are trying to troubleshoot a problem, evaluating reasonable possibilities for the cause can help you avoid wasting time pursuing the wrong problem. Socrates, the Greek philosopher, asked questions to investigate philosophical problems. Asking questions about a support issue. Here are some example questions you can ask when presented with a support issue and the purpose of asking them. Under what conditions does the problem occur? You're trying to find a cause and effect relationship. If there's no pattern that gives rise to the problem, it might be more difficult to troubleshoot. What was done just before the problem started appearing? This is a more specific cause and effect question than the last question. It gets the user who reported the problem to think about specifically what they were doing before they experienced the problem. Has this problem ever occurred in the past? You're attempting to determine if there's a calendar condition involved. If a user says they saw the same problem about this time last year, there might be something occurring each year that is related. Have you noticed any other problems with your device or service? You're trying to determine if the problem is specific or broad. For example, the user might say they notice the problem when using a particular application. However, if all applications on the device are having problems, take that as a pointer to something on the device and not the application itself. Environmental factors. Today you turn on your device and an application or service that worked fine yesterday is no longer working. As far as you know, nothing changed overnight. But something did change, and that change caused the problem. The change might not have been made to the device. It might have been in its environment. When a problem is caused indirectly by something happening in the computing environment, this is an instance of an environmental factor. Check environmental factors. Suppose you're working as an IT professional and you find 5 support requests from users who claim that their work laptop crashes as they attempt to open it. You check for updates to the user's operating system and applications and verify that no updates were rolled out overnight. Even without interviewing the users, you know the following. All 5 users are experiencing a problem with the same application. All 5 users are experiencing the same problem. None of the devices or applications were updated overnight. Then you might move your attention in the direction of an environmental factor as the cause. You might consider that the laptops your organization uses rely on cloud services to run properly, and you check the status of the cloud service. You learn that there's a problem with the login provider for that service. You dig in a bit more and learn that there's a bug in the application which causes crashes if the operating system is not able to communicate with the login service. Environmental factors can be difficult to track down in complex environments because the cause of a problem can be so many different things. Clearly understanding the symptoms and ruling out some factors and focusing on others will help narrow the options when you are looking for an environmental cause. Find and fix an environmental factor problem. Follow this scenario to walk through the steps to find and fix the environmental problem. Scenario: your printer will not connect to your wireless network. You want to find out if the problem is an environmental factor. Follow these steps. Step 1. List any recent changes. You installed a new printer cartridge yesterday. Your internet service provider recently raised your data limit. There was an operating system update. Earlier today the lights flickered and you had to reset your clocks. Step 2. Check for environmental factors. Your internet service provider has not reported an outage in your area. The printer is free of dust. The room temperature is not too hot or too cold. The humidity is not too high. Step 3. Check your system. Your power cord is plugged into the wall outlet and other appliances on this circuit are working properly. The printer is turned on. When you refresh your browser, the website shows new content. The printer driver settings are correct. Step 4. Discover the problem. If other appliances on the circuit are not working properly, your power might have been affected by a power surge at the same time the lights flickered and the clocks went out. If the printer is not turned on, it would not be able to connect to the wireless network. If the website does not show new content, the network might not be connected. If the printer driver is not up to date, the operating system update might have caused a conflict between your printer and other devices on the network. Step 5. Summary. You went through basic troubleshooting steps to determine if the printer problem is environmental. By checking the printer, the network, and even the temperature, you narrowed down the possible problems. This approach also helped you determine whether the problem was environmental or directly related to the printer itself. Induction or deduction, or both. Being an expert troubleshooter will mean you'll need to use both induction and deduction. Induction, or inductive reasoning, is working with a narrow set of data and expanding to a generalization. Deduction, or deductive reasoning, is taking a broad set of data and attempting to come to a specific conclusion, like a cause. Here's an example of a problem you might need to solve using inductive reasoning. A user contacts you and states that every time they attempt to use their card key to unlock the shared printer, they get a warning on their phone that their password is about to expire. But they recently changed it. You then talk to other employees and they report the same behavior. You draw the conclusion that all other employees will have the same experience. From that conclusion you decide to investigate the card verification system on the printer to learn why the alert is occurring. You used a small amount of data, the report of 6 employees, to draw a general conclusion that everyone in the company will experience the same problem. Here's an example of a problem you might need to solve using deductive reasoning. You've noticed some network symptoms like dropped connections, incomplete downloads, and general slowness across the network. You also have been getting network alerts that the amount of storage space on your cloud provider has been shrinking. You've gotten complaints from some users that their emails won't send with a message that the attachments they're sending are too large. As you investigate further, you learn that some employees you support have been downloading large files each day. You spend more time looking into things and learn that the company changed the style of images it uses in its marketing material. They not only changed the image resolution but the provider that supplies the images. After all this investigation, you formed a theory that the larger images are impacting network capacity, storage, and the ability to send the images files to partners that need them. You used various symptomatic data to deduce that the symptoms are caused by a single change, which was the way the company manages images. What's an easy way to tell the difference between inductive and deductive reasoning? Inductive reasoning uses a bottom-up approach. You make a generalization from specific observations and facts. Deductive reasoning uses a top-down approach. You use available information, knowledge, or facts to make a conclusion. The Sherlock Holmes method: think creatively. Sherlock Holmes is a brilliant detective who first appeared in Sir Arthur Conan Doyle's novels during the 19th century. Holmes used deductive reasoning and creative thinking to solve mysteries. Sometimes a problem seems very difficult. You ask a lot of questions, apply inductive and deductive thinking to the problem, and attempt to discover the root cause of the issue. Regardless, you are not able to find the cause of the problem. In these cases, you will need to look at causes that you might initially evaluate as improbable. Thinking creatively can work to your advantage when you are troubleshooting, which you will see in the following example. Suppose you're troubleshooting this problem: an overhead light in your home won't turn on. You start to troubleshoot. You check the breaker panel, and the breaker is fine. You replace the light bulb and turn on the switch, but still no light. You confirm there is power to the switch. You check the light switch itself. Suppose you try it in another place in your house, and determine it's in working order. You also test the light socket. When the switch is on, the socket is getting power. You even test the electrical wires between the switch and the light and determine there's no short. So far, what might you conclude? You now conclude the following. There's no problem with the wiring. The switch is getting power. The switch is in working order. The socket is in working order. The light has a new bulb. And now, you think creatively. This system is a fairly simple one, so there are not a lot of other options for where the problem might be. If you were to evaluate the probability that the new light bulb you put in the socket was faulty, it would be fairly low, at least intuitively. For that to be the problem, you'd have to conclude the original bulb was faulty and the new bulb you put in also was faulty. Your mind might tend not to go there because it seems highly improbable that this would be the problem. But since everything else seems to be working as it should, you can eliminate those as the reason for why the light won't turn on. You decide to test the improbable and grab a bulb from a lamp you know works. You screw it in, turn the switch on, and the light comes on. The old bulb and the new bulb were both faulty. Including the highly improbable as a possible cause of a problem is a troubleshooting methodology. The approach embodies the concept attributed to the literary character Sherlock Holmes. Once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. Using troubleshooting. An employee of the firm you support submitted a support ticket that indicates that they are not able to print from the shared printer. They are able to print from their word processor, but the document never shows up at the printer. Practice using your troubleshooting skills on the printer in the following image. 1. The printer might be too close to the wall. That's a great environmental factor to check. 2. The paper looks okay, but the tray might be jammed in the back. That's a good use of root cause thinking. 3. The case might feel hot. Checking for overheating is a good application of environmental factor thinking. 4. The controls might be set wrong or show that the printer is not on. Checking them one by one is a good way to eliminate possible causes. 5. Are the cables connected properly? If the power supply is hidden behind furniture, this issue might have been missed. 6. The printer stand is probably not causing an issue with the way the printer is functioning. In some cases, an unstable support may be a problematic environmental factor. You looked at all the right things to rule out an environmental issue. If everything you evaluated checks out fine, the problem your employee is having is likely something else. Perhaps you need to check the network router next. About this module. Module 2. Troubleshooting methodology. Troubleshooting methodology. Introduction. In this module, you will walk through basic troubleshooting techniques step by step. You'll learn how to get past a perceived problem by examining symptoms to evaluate the root problems. You'll explore how to construct a theory and develop an action plan to solve the problem. Learning objectives. After completing this module, you should be able to list the typical steps in a troubleshooting methodology. Identify ways a user's description of a problem can be inadequate. Explain a technique to examine symptoms. Describe a method for creating a theory about the root cause. Explain what makes up an action plan. Describe the importance of collaboration when troubleshooting. Methodology overview. When troubleshooting, IT support professionals have a methodology. Methodology. A methodology is a general strategy that guides activities within a process. It provides a framework for how to proceed with methods and techniques to obtain answers or results. While there is no prescribed troubleshooting methodology, these are the typical steps that represent how to successfully troubleshoot. 1. Understand the perceived problem. 2. Examine the symptoms. 3. Evaluate the problem. 4. Create a theory of most probable cause. 5. Develop an action plan. 6. Experiment with solutions. Step 1. Understand the perceived problem. There's an old adage that says that if 3 people witness an accident, you'll get 4 different stories about what happened. The first step in a typical troubleshooting methodology is to understand the perceived problem. Everyone has a unique point of view and some people have more than one. Because of this, support requests can be challenging to understand. As an IT professional, you might get support requests that sound like the following. My computer doesn't work. I hate our word processor because it always misspells things. Why aren't you able to get new software? Why am I not able to send text messages? I put a thumb drive in my computer. Nothing happened. I pulled it out and put it back in again multiple times but nothing happened. Now it seems the slot where I put in the thumb drive in is broken. How do I get the files off of my thumb drive? Each of these statements represents a perceived problem. They're all challenging to address because they're one or more of the following: unclear, vague, off-point, high-level, imprecise, meandering, and ambiguous, to name a few problems. Many times, people create support requests while they are emotional, which can interfere with their being precise. Working through emotions. As an IT professional, you'll spend time helping people work through their emotions and providing clarity and precision on the problems they're having. Step 2. Examine the symptoms. The next step in a typical troubleshooting methodology is to examine the symptoms. Since as early as the Greek philosopher Aristotle's time, people have recommended the 5 Ws as fundamental to a problem-solving toolkit. To examine symptoms and get to the root of a problem, answer the following 5 key questions. Who caused or is harmed by the problem? What is the problem? Where is the problem occurring? When does the problem happen? Why is it happening? Fill in the gaps. The people you support will tell you what they think is the issue. The description they give you might exclude one or more of the Ws. Your job is to fill in the gaps. People start with their perspective, so you have to start there, too. Non-technical people might not have the vocabulary to accurately describe a technical issue. They might not know how to communicate what is going on and might use general or vague terms. They might be upset or confused, which may further affect their ability to communicate clearly. You must empathetically listen to what they're explaining and work to interpret their concerns into the 5 Ws. You might have to ask them many questions and request a demonstration of the problem, a photo or a screen capture for you to get a baseline of the problem. Baseline. A baseline is the fundamental information you need to start troubleshooting. Step 3. Evaluate the problem. Once you have baselined the issue, you get to work. With the 5 Ws, you have an approach with which to explore the cause of the problem. Keep in mind that your evaluation of the problem might change over time. Your initial evaluation of what the problem is might not be the same when you finish. Your goal is to find the problem's cause or causes. When you think this way, the symptoms the user describes are the effects produced by the cause. The relationship between the cause and effect might not always be direct. But the cause will be something that will stop producing the effects once you've addressed it. Using scientific methods. Your task when investigating a problem as a support professional is a scientific one. You start with the end of the chain of events and work backward to the cause. Deductive reasoning is a core scientific approach. Another key principle in the scientific method is identified by a big word, falsification. You can see that this word is related to the word false. Falsification is the practice of trying to prove a theory false. The thinking is the harder it is to prove a theory false, the more likely it is to be true. When you're troubleshooting a problem, you might not be able to prove your theory correct by producing hard evidence that the conclusion of your theory is a fact. If you're in one of those situations, falsification might come to the rescue. You, or a colleague, can try to find evidence that it's false. If you can't prove it false, your theory will appear to have more weight. For example, suppose your company's accounting software is giving inaccurate report data. Your colleagues have focused on the theory of user error. They reason that it's unlikely for an accounting software package to have a calculation bug. You suspect that a bug in the software is the cause of the problem. But because you don't have access to the code, you can't point to the badly written code in the accounting software. You can't prove that your theory is right. You might try to prove your theory wrong by finding a single case where the software calculates numbers for the report accurately. If you can't find a single case, your theory will gain credibility. If you do find a single case, your theory will appear to be false because a software bug would most likely always display the same symptom. Step 4. Create a theory of most probable cause. Sometimes it is difficult to find causes for issues in a complex technical environment. There might be many reasons for a given symptom which you're addressing. After you've evaluated the problem, you need to develop a reasonable theory for what's causing it. You strive to make your theory evidence-based, based on what you've learned about the problem, discovery, you hypothesize about its cause. Experience will help with developing a solid theory. Experience provides opportunities to learn a space deeply. The better you know a technology, the easier it will be to theorize about what might cause problems. If you're working in an area where you don't have much experience, work with others who do. Whether you're an experienced technician or just learning, it's always a best practice to run your theories by other colleagues to ensure you haven't missed anything. Your theory should have the following 4 characteristics. Precise. A theory of cause that's too broad makes it difficult to pinpoint a problem. Actionable. Because your goal is to solve and resolve the problem, the theory describes the actions you can take to fix the problem. Evidence-based. Evidence helps you track your line of thinking and to collaborate with others because they can follow how you arrived at the conclusion. Flexible. The theory must not be so rigid that you don't allow room for other possibilities. It is a theory after all. What are the qualities of the theory? Good writing will support a good theory. Compare the following examples to see how important good writing is for a theory. Example theory number 1. There's a problem with the hard disk. Precise? No. Actionable? No. Evidence-based? No. Flexible? No. Example theory number 2. I believe replacing the controller card on the hard disk will resolve the problem. The fact that a different disk drive works in the computer indicates that it's probably not the disk drive cable or the computer's motherboard. There is a charring on the disk drive's controller card that points to a potential electrical surge. Finally, the disk drive is getting power, but the power indicator light is not coming on, pointing to a problem with the controller card. Precise? Yes. Actionable? Yes. Evidence-based? Yes. Flexible? Yes. What do you think? How would you better write this theory to make it precise and actionable? The wireless network is down. Type your response in the following text box. When you are finished, select Done. Writing an answer is a good way to process your thoughts. These answers are for your use only. You have the option to download your response and save it. It will not be saved in the text box when you move on in the course. Evaluate your thinking. Does your answer account for the following? First, the theory isn't precise because it doesn't attempt to describe why the network is down. In order to make the phrase more precise, you should include statements that describe specifically what might be wrong with the wireless network or what caused it to be malfunctioning. To make the theory more actionable, you can describe specific steps you will take to try to address the symptom. For example, I'll restart the router and see if the wireless network works properly. I believe the issue has to do with someone changing the wireless network's password and will test a connection with the old password to verify if it works. Based on other reports, the wireless router might be malfunctioning and need to be repaired. I will run diagnostics to determine if there's an issue with the hardware. In conclusion, a better written theory is precise and actionable, describing what you suspect the issue is and what steps you'll be taking to test your theory. Step 5. Develop an action plan to address the cause. An action plan describes the specific steps you intend to take to address the cause and resolve the problem. Simple problems might not have an elaborate action plan. But documenting your actions, even if the action plan is just a few steps, will help you retrace steps and remember what you did if you see the problem again in the future. Step 6. Experiment with solutions. You attempt to find the root cause, examine the symptoms, and develop a solid theory and action plan. You test your action plan to find out if your troubleshooting techniques might work. But maybe you don't find the problem and it's time for more experimentation. When troubleshooting, expertise is important, and persistence is just as important. In these cases, you'll need to develop alternate theories. Many times, your evidence won't change but your theories will. You'll have to develop a new theory based on the same evidence that supported your old theory. Reset your approach. In some cases, your theory is correct, but the steps you took to correct the problem weren't right. For example, suppose you're troubleshooting a cloud services problem. Your users are trying to run a report, but when they load it, they get a message that says, "No data is available for this report." You suspect that the web service that provides the data isn't communicating with the report tool. You restart the tool and the web service, but the problem persists. After more investigation, you realize that the report tool is holding on to its cache, stored data, longer than it's supposed to. It's a bug in the software. You clear the cache and the data starts appearing. Your theory was correct. The web service wasn't sending updated data to the report tool. The solution wasn't to restart the web service. It was to clear the cache in the tool, which got the data flowing. Think creatively and act collaboratively. When you just can't seem to solve a particular difficult problem, thinking about the problem in a new way can help arrive at a solution. For example, suppose a user asks for help because their internet connection continually drops. You try all the software solutions you can think of, you check all the cables and Wi-Fi settings, you check the router, and even replace the network card in their computer. Nothing appears to work. Shift your focus. You know the connection is dropping. Instead of thinking about this as a network problem, you decide to explore it as a power problem. The connection dropping might mean the network card is not getting the power it needs consistently. You check the power supply in the computer and discover that it's older and doesn't provide consistent power to the computer. It dips and surges. Most components in the computer seem to accommodate the inconsistency, but the Network Interface Controller, NIC, for that model computer needs consistent power. You replace the power supply, and the problem is resolved. Using the experience and expertise of others can help get past intractable problems. Sometimes all that you need is a different point of view. Others might have expertise in areas that you lack. Working with others to explore solutions can be fun, too. Review the troubleshooting methodology. You've learned about a typical troubleshooting methodology and the techniques that professionals might implement in each step to 1. Understand the perceived problem. 2. Examine the symptoms. 3. Evaluate the problem. 4. Create a theory of most probable cause. 5. Develop an action plan. 6. Experiment with solutions. Match steps to troubleshooting techniques. Consider the techniques you learned across the troubleshooting steps. In which step do you implement the following technique? Explore more. It's valuable for you to know about the Computing Technology Industry Association, CompTIA, opens in a new tab. It's a non-profit organization and leading provider of vendor-neutral and industry-recognized IT certifications that you can consider. CompTIA offers an IT troubleshooting methodology, much like the steps you just learned about. It's a 6-step process that frames the problem and guides IT professionals to identify and execute a solution. Take a moment to check it out. About this module. Module 3. Documentation for IT support. Introduction. In this module, you'll learn the value and role of good documentation when supporting users and devices. You'll explore techniques for keeping good documentation, when to use a checklist, and the value of sharing your learnings with others. Learning objectives. After completing this module, you should be able to explain ways to use a checklist to track work. Describe the importance of legal and compliance protocols. Describe methods of documentation. Explain why documentation is important in support work. The checklist principle. Imagine you're taking a big trip. You have a number of things you need to get done before you leave. You have tickets to buy, bags to pack, a passport to renew, ground transportation to arrange, and excursions to schedule. You can take a couple of approaches to manage this trip. Try to remember everything or write it all down. Keeping a list is a popular and time-tested way to keep track of work items in a complex environment. When dealing with support issues, keeping a checklist will ensure everything gets done and will save you time. Many companies not only require a checklist but will also provide a template you can start with. In some corporate environments, evidence that certain tasks were accomplished can be a legal requirement. Checklists can help keep track of what has been done and what is still open. Here is a list of important items to include when you are creating a checklist. Atomic, cover a single task or objective. Actionable, start each item with a verb to describe what needs to be done. Date-driven, work to include a complete by date for each task. Sometimes this will be challenging if there are unknowns, but it will help you to see the overall flow. Prioritized, assign each item with a priority relative to other tasks, so you know what to do in which order. Dates can help with prioritization. Categorized, sort tasks by type. This is more of a nice to have, but the best task lists typically organize work items into categories. For example, for a support problem, you might have a customer communication category, a documentation category, and a management report category. Security and compliance protocols. Many industries are regulated and require compliance. This generally means that all OR part of the business in that industry is subject to governmental rules and oversight. Examples include industries that impact safety, such as the automotive industry. Security, such as the defense industry. Economics, such as the financial industry. Complying with regulations. If you're an IT support professional in one of these businesses, you'll need to be aware of and adhere to the rules of that industry. One requirement might be that you document the work you perform on a user's device. And you might be required to keep a log of all customer conversations. Even the software you install, or don't install, on employee computers might be regulated. Keeping good documentation is always a good idea, even in non-regulated industries. Journaling and logging work completed. While checklists help you keep track of work you will need to do in the future, journaling and keeping a log help you keep track of work you are doing now and work you have completed. Managing ongoing work involves change and interruptions that might distract you. You might be working on many requests at a time. Emergencies arise that will require your immediate attention. Customers failing to respond might delay your ability to resolve the issue. For these and other reasons, keeping good notes will help ensure that details don't get lost. Keeping track involves a time investment that you'll need to commit to making. But if you develop a discipline in keeping good notes, you'll save yourself from hours of rework and lost work. There are many models you can explore to organize the notes you keep. Your organization might have a model they'd like you to use, or you might find a model for yourself. A popular and effective model is called the PARA method. Developed by Tiago Forte, PARA stands for Projects, Areas of Responsibility, Resources, Archives. You can use PARA to organize your journal or notebook into these 4 areas. Then for any support request you're working on, you can keep notes in one or more of these notebook sections. Keeping good notes is the first important step. Being able to find and use them is an important next step. A model like PARA can help you keep your notes organized and useful. Explore more. Check out the PARA method, a universal system for organizing digital information. Forte Labs opens in a new tab to learn more about using the PARA method. Sharing solutions with others. Imagine you worked for a couple of weeks on a particularly difficult problem. You finally sorted it out and kept excellent notes throughout the process. You documented your thinking as well as the technical aspects of the solution. You now have another addition to your own documentation for future cases. You can amplify the impact of your learnings by sharing some or all of your notes with your colleagues. Many organizations have an internal knowledge base. This is a dynamic library of support problems and solutions, created by the professionals who are working on them. If your organization does not have a knowledge base, consider using open source software like DokuWiki, opens in a new tab, to create one yourself. Then share it with your group. What do you think? Think about information you would need to keep about your work or school and how you share it with users, colleagues, teachers, or fellow students. What are some best practices that you might use to record and keep track of this information? Type your response in the following text box. When you are finished, select Done. Writing an answer is a good way to process your thoughts. These answers are for your use only. You have the option to download your response and save it. It will not be saved in the text box when you move on in the course. Evaluate your thinking. Does your answer account for the following? Did you consider basics like dates, names, addresses, email and postal service, and contact preferences? Adding user histories is also important and will help you learn how to work through emotional issues and improve user satisfaction. Using a system that lets you aggregate the data and sort requests into frequently asked questions, FAQs, will help you identify trends and gaps. You can share this general information with the people you support. About this module. Module 4. Remote Troubleshooting. Introduction. This module will explain how you can troubleshoot problems for users and devices in remote locations. You'll explore tools and methods you can use to solve problems when you don't have direct access to the devices you need to work on. Learning objectives. After completing this module, you should be able to Describe techniques for troubleshooting problems remotely. Describe tools for remotely troubleshooting problems. Explain the purpose of writing scripts to troubleshoot problems remotely. Remote Troubleshooting Toolkit. Remote troubleshooting tools have been around for many years. Since COVID-19, remote tools have improved and there are more of them. Imagine you're an IT support professional for a large sales team. The team works remotely most of the time. They're either on the road or at their homes in remote locations. Your support mainly consists of laptops and mobile devices. While talking through issues can solve many problems, sometimes you need to work directly on the device that has the problem. Use troubleshooting tools. An IT support professional has a toolkit for addressing support needs with software tools and techniques. You would use both types to support users remotely. When email, support tickets, or chat isn't sufficient, and you need to work directly with the device needing support, you can use tools that are specifically designed for remote support. Check out a few of these special tools. Similar machines and virtual machines. Many corporate environments require that employees use a narrow set of devices. This policy makes it easier for the IT department to manage these devices. When troubleshooting remotely, IT support professionals can have one or more of each type of device that employees are using at work. They can use one of these devices to remotely support a user with the same device. An organization's users will have various configurations and software setups that can make it challenging for a support professional to replicate. Virtual machines, VMS, can help in these situations. A VM is a software representation of hardware. When a VM is running, it looks and behaves as if it's a separate device. For situations where special software requires very specific device configuration, IT support professionals can use a VM to mimic that configuration. Screen captures and videos. Sometimes a user will get a very specific error code. For example, sometimes browsing the web, users might see error code 404 not found. This indicates that the page at the address they put in their browser's address bar doesn't exist. Users also will experience something that can be very difficult to replicate remotely. In these cases, having the user take a screen capture and send it to you can be irreplaceable. When working on a laptop, tablet, or desktop or using a device other than their mobile phone, users also can take short videos that show the problem. Screen sharing. Most laptop and desktop operating systems support screen sharing tools. These tools enable a remote operator to see and sometimes control the remote device. Although these tools are limited to certain types of devices, they can make support easier because users don't have to install and configure separate software. Remote troubleshooting tools. There are many different tools that you can use to access and control remote devices. Video conferencing tools that many organizations use have screen sharing options that can be ideal for troubleshooting. There also are purpose-built tools that IT support professionals can use to view and control remote devices. For example, IBM offers the Assist On-Site tool, Microsoft provides Windows Remote Desktop, and Google has a Chrome Remote Desktop. Using scripts to work through common problems. Small computer programs are called scripts. You can write scripts to target specific problems. A script generally does not have to be compiled, meaning changed from human-readable code into computer code. Scripts tend to be fast and easy to write. What a script looks like. The following example is a script that displays the message "Hello, world." This script is written in the Python programming language. Write a script. Imagine you have to work on a problem where a remote user's laptop has slowed down so much that it's almost unusable. You've had them look at a variety of things, but nothing seems out of order. You verified that the laptop doesn't have a virus. The user is on a slow internet connection, so using a remote tool isn't feasible. A script might be a good option in this situation. System logs. You can create a script that will produce a system log. A system log is a text file that gives information about the computer. It can provide information like recently updated files, process information, perhaps there is a program that has frozen, and information about the memory usage on the device. To help the user remotely, you write a script that outputs a system log that the user runs. Then the user sends the result in a log back to you. After some investigation, you learn that a recently updated system component has a bug that can cause the central processing unit, CPU, to race. You direct the user to roll back the update. That solves the problem. Choosing a remote troubleshooting technique. Say you work in IT supporting a group that has some users who work in an office and some users who work remotely. Users in your group have a choice of printers. Some users share a networked laser printer and others have their own inkjet printers. You have identified an issue with a remote user's printer. What do you think? How would you remotely troubleshoot issues with the printer? Consider the following approaches. Type your response in the following text boxes. Writing an answer is a good way to process your thoughts. These answers are for your use only. You have the option to download your response and save it. It will not be saved in the text box when you move on in the course. Evaluate your thinking. Do your answers account for the following? For question 1. Would a video conference be a good tool to troubleshoot this issue? Why or why not? This is a very good choice. A video conference will let the user share their screen and their environment. You can ask them to open their printer settings and watch them make changes. You can even ask them to pan their camera around the printer and watch them check for physical issues under your direction. For question 2. Would a virtual machine, VM, be a good tool to troubleshoot this issue? Why or why not? This is a good choice. A virtual machine, VM, will let you work on a mirror copy of the user's device. For question 3. Would writing a script be a good technique to troubleshoot this issue? Why or why not? You might want to reconsider this choice. While a script might be useful, writing a script for a printer issue would probably be a solution of last resort. You've come so far and learned so much. You explored the intriguing world of troubleshooting. You learned to troubleshoot problems that don't have an obvious solution. Now that you've completed this course, you should be able to define troubleshooting, explain basic troubleshooting methodology, identify key disciplines when creating documentation for support tasks, explain methods and best practices for effective remote troubleshooting. Key points to remember. 1. Troubleshooting is an approach to solving a problem. 2. Getting clarify on what the user is experiencing helps ensure that you are not investigating the wrong problem. 3. You can evaluate reasonable possibilities for the cause of a problem by using the Socratic approach. 4. When looking for an environmental cause of a problem, understanding the symptoms and ruling out some factors so that you are able to focus on other factors might help narrow the options. 5. Induction involves using specific observations and facts to form a general conclusion. It's a bottom-up approach. 6. Deduction involves using general observations and facts to form a specific conclusion. It's a top-down approach. 7. Including the highly improbable as a possible cause of a problem is a troubleshooting methodology. 8. When people create support requests emotionally, their descriptions might not be precise. 9. The 5 Ws to ask are: who caused or is harmed by the problem? What is the problem? Where is the problem occurring? When does the problem happen? Why is it happening? 10. Experience helps to developing a solid theory of probable cause. 11. Good theories are precise, actionable, evidence-based, and flexible. 12. Documenting your steps in an action plan might help you when you need to remember your approach to a problem. 13. Checklist items are atomic, actionable, data-driven, prioritized, and if possible, categorized. 14. Documentation might be a regulatory requirement. 15. Remote troubleshooting tools are helpful when you are not able to see a user's screen or device. 16. You can write scripts to work through common problems.